Everyone. Today we're going to do an introduction nomenclature video, and the first subject we'll be looking at is hydrocarbons, and specifically alkane, alkene, and alkyne. So hydrocarbons, to start off, are compounds that only contain hydrogen and carbon, and there are three different types: the alkanes, the alkenes, and the alkynes, as mentioned. So an alkane is a saturated hydrocarbon with only single bonds between carbon atoms. An alkene has to have a double bond, and alkyne has to have a triple bond between carbons. And these little formulas I have written down here are the ways to get the molecular formula, depending on N, and N is the number of carbon atoms you have. So pretend it would be 3 carbon atoms in a chain. You would have C3H 2 times 3 plus 2, so C3H8 would be the molecular formula for a 3-carbon alkane. Okay, so moving on, we have 3 different diagrams that we can represent alkanes with: a structural diagram, condensed diagram, and a line diagram. And actually, these 3 pictures I have here represent the exact same molecule, just in 3 different ways. So a structural diagram fills out the bonds between carbons and hydrogens, and this is an example that has other molecules in it. So right now, that's not a hydrocarbon to us. It was just an example of the 3 kinds of diagrams. A condensed diagram just shows the bonds between carbon atoms. And a line diagram just gets rid of all of the atoms that are carbon and hydrogen and represents them as sticks instead. So this is probably going to sound like a lot of information to throw at you for the first run through, but this handout will be available to you guys, so run through it once on your own before watching the video, and the video will also always be available as well. So right now I'm just going to read the rules out, but then we're going to go through examples of how to actually name molecules, and hopefully it'll all come together. So the first rule is identifying the longest carbon chain, and it has to be a continuous chain that you're looking for, and we're going to call that one the backbone. So number 1 and 3 talk about naming and finding and numbering the backbone. Any portions of a molecule that are not included in that backbone get called the branches or the side chains. And then you want to number the carbons along the backbone so that those side chains get the lowest possible position. Depending if you want to number it from left to right or from right to left, the side chain will fall on a different number of carbon. So you want it to fall on the carbon that has the lowest number possible. So once you have your backbone figured out, you can use this chart and this shortcut down here to name the molecule. If you have this number of carbons in your backbone, you're going to use this prefix. So for example, if you have 4 carbons in your backbone, it's called but as the prefix. And depending on the number of bonds in between the carbon atoms, it can get called ANE, ENE, or YNE as its ending. So for alkane, alkene, and alkyne. So if I had a 4-carbon molecule that had single bonds, it would be called butane. And then this is the molecular formula example here. So that's all summarized down here below. And then the last thing we have to cover is how to name the side chains. When you're naming the side chains, you number the carbons, follow this chart, find your prefix, but then it's YL, that's the ending that you put. So if my side chain was a methyl, which means a 1 carbon, it would be 5-methyl. And then my backbone is known, so it has 9 carbons and single bonds, so nonane is the backbone ending. And that would be the formula for the molecule, or the name for the molecule, sorry. So some things to remember. When you're putting numbers and words beside each other, they get a dash, so 5-methyl. And when you're putting numbers beside numbers, you get a comma, so 5-6, for example. If there are multiple of the same branch, you list those branches as di if there's 2, tri if there's 3 of those branches, and so on and so forth. And when you do have that option of multiple branches and you're wondering how to order them in the final name, you want to put them in alphabetical order. So the ethyl needs to be listed before the methyl because E comes before M. Okay, so try put that together now in these 2 examples. I started off with alkanes. So this would be if we go back to the types of diagrams, this is a condensed diagram because it only shows the bonds between carbons. And then I'm going to redraw it as a line diagram to show you guys how to do that as well. So the line diagram, every vertex or end point of a line has a carbon at it, and you have to fill out the number of hydrogens. So you know a carbon has 4 bonds it can make around it. So for a full octet, or if you want to say has 8 electrons around it, to be more exact, you would need to fill out 3 other hydrogens. So 1 bond here and 3 to the hydrogens make up that 4. But we're just going to summarize that into a stick. So a carbon there and a carbon at the vertex will be these 2 carbons here. Another stick is to this carbon, which would be this vertex. So keep going until you have the right number of vertexes. So 1, 2, 3, 4, 5, 6, 7, because we have 1, 2, 3, 4, 5, 6, 7. Vertexes or bends, however you want to say it, but make sure you just have the right number to represent the number of carbons. So this would be the line diagram now for this molecule, but how do we name it? We can go back to represent 7 carbons as a hept. That's a prefix we want to be looking for. So we start with hept. And all single bonds, so the ending would be ANE for alkane. We can go to the next example below. So first step here would be a little bit different because we want to now find the backbone. We want to find the longest continuous chain of carbons. So we can just practice. Let's try 1 here, 2, 3. That would be a 4 chain, but probably not long enough. We could go bigger. So let's try put 4 down here, 4, 5, so 6. 6 would be my backbone. And 6 follows with hex as the prefix. And again, all single bonds between carbon atoms, so hex ANE for alkane. And now this is my side chain. So my side chain only has 1 carbon between it. Then we go to our chart and 1 carbon gets meth. So it would be meth. And the ending for side chains get YL. So methylhexane. And we just have to list the number of the backbone carbon that side chain comes off of. And we want that number to be the lowest number. So I ordered it from top down so that it fell on a 3, which would be the right answer. So it should be 3-methylhexane. But just to show you the other option, if I numbered it bottom up, it would be 1, 2, 3, 4, 5, 6, and then that number would be 4 that I would have to list here. So that's the wrong answer. Don't put 4. It would be 3-methylhexane as the right answer.